Section 7.3, Part B. Anytime that you have a system of equations in which you have less equations than you do variables, you know right away, before you do anything else, that there are infinitely many solutions to this system. And when we know that there are infinitely many solutions, we're going to start out right away. And we're going to let z equal a. So once again, we know our ordered triple that we're going to have for our final solution is always going to have a z coordinate of a. So all we need to do now is take these two equations and eliminate either x or y. Does not matter which one. Let's say that I'm going to eliminate x's. If I do that, I need to multiply this top equation by negative 2. We get negative 2x plus 4y minus 2z equals negative 4. Second equation, leave alone. 2x minus y minus z equals 1. Add them up. X's are gone, which is what we wanted. 3y minus 3z equals negative 3. Remember, though, we know that z is equal to a, so we can solve right away for y in terms of a. Divide by 3, and y is going to equal a minus 1. Next, let's go ahead and find x. If I use that top equation, x minus 2 times y, which we now know is a minus 1, plus z, which we know is a. Solve for x now in terms of a. Distribute that negative 2. Add like terms. Move everything to the other side away from the x, and we get x is equal to a. So we have the order triple a minus 1, and a. There's our solution to that system. Number 6. All three variables represented in all three equations. I'm going to eliminate x's here. So if I'm going to eliminate x's using these top two equations first, I need to multiply the top equation by negative 2. When I do that, I get negative 2x minus 4y plus 14z equals 8. Second equation we're going to leave alone. 2x plus y plus z equals 13. Add them up. X is gone. Negative 3y plus 15z equals 21. Now I need to take a different combination of two equations and eliminate x's once again. If I take the top two this time, I'm going to take that top one this time and multiply by negative 1. Rewrite it right under here. Negative x minus 2y plus 7z equals 4. Now add those up. X's are gone. Y minus 5z equals 7. From here, take the two equations now that we have in terms of y and z, solve them by substitution or elimination. If I multiply this equation we just found right here by 3, move it up here to eliminate y. So we get 3y minus 15z equals 21. Sorry, this should have been a negative 7 here, so this is a negative 21. Y's drop out, z's drop out, constant drops out. We're left with 0 equals 0. So right away, without going any further, we know this system has infinitely many solutions. Since we know there are infinitely many solutions, we're going to go ahead to our next step, which is always to let z equal a when we know there's infinitely many solutions. This equation right here, y minus 5z equals negative 7. I know z is equal to a, so I can solve this pretty easily for y. In terms of a, y is going to be 5a minus 7. And now we just need to find x. I'm going to take the top equation, I'm going to plug in and solve for x. So we have x plus 2 times y, which we just found to be 5a minus 7, minus 7 times z, which we know is a, equals negative 4. Simplify, distribute the 2 through. Add like terms. Move everything to the other side. We get negative 3a plus 10. So our ordered triple, x is negative 3a plus 10. Y we found to be 5a minus 7. And z we know is always equal to a. So there's our general solution. Third one. Given s is equal to that equation, find a of 0, v of 0, s of 0 under those three sets of conditions. So from each of these, we're going to come up with a different equation, 3 different equations, as a matter of fact, from each piece of information, and use that then to solve the system. So our first one, we plug in t equals 1 and s equals 52. So I'm putting 52 in for s. I'm going to plug 1 in for t and simplify as I go. 1 squared is 1, so we're just left with 1/2 a of 0. Put 1 in for t there. We just have v of 0 plus s of 0. There's our first equation. Second equation, now I'm going to use the second pieces of information. 52 equals, we're plugging 2 now in for t. So 2 squared is 4. 4 times 1/2 is 2 a of 0. Put 2 in here for t. 2 v of 0 plus s of 0. Third equation is going to come from that information. This time s is 20. T is 3. 3 squared is 9, so we have 9/2 a of 0 plus 3 b of 0 plus s of 0. So now there's our 3 equations, 3 unknowns. The only thing different in those types of problems, you're not going to be given the equations directly. You're going to have to plug in the 3 pieces of information to come up with your own equations. If you notice in these equations, the easiest variable to eliminate right away is going to be s of 0. If I look at these 2 equations right here, top 2, and we want to eliminate s of 0, I can just take the top equation and subtract off this entire bottom equation. So I'm going to get 52 minus 52 is 0. 1/2 minus 2 is negative 3/2 a of 0. V of 0 minus 2v of 0 is negative v of 0, and the s of 0 is canceled. I'm going to do the same thing here now with these bottom 2 equations. I'm going to take the second equation and subtract off this third equation. So I have 52 minus 20. 2 minus 9/2 is negative 5/2 a of 0. And 2 minus 3 gives me negative v of 0. So now I've eliminated s of 0 from both equations. I have 2 equations, 2 unknowns. If I look at the form that these 2 are in, we can use elimination right away and get rid of the v of 0s. 0 minus 32, negative 3/2 plus 5/2 is just 1. And our v of 0s drop out, so there's our first variable. We know a of 0 is negative 32. Plug back into this equation right here, and let's find now v of 0. So we have 0 equals negative 3 halves. We just found a of 0 to be negative 32 minus v of 0. We get v of 0 to be 48. And finally, if I know v of 0 and a of 0 now, we can plug back in wherever we want and find s of 0. If I use this top equation, 52 equals 1 half a of 0, which we know is negative 32, plus v of 0, which we know is 48, plus s of 0. We get negative 16 plus 48 is 32. S of 0 is going to be 20. So there's our three variables. And now the final thing that you're going to be asked to do in these problems is rewrite the equation with everything substituted in. So we get S equals 1 half a of 0. Well, a of 0 is negative 32. 1 half times negative 32 is negative 16 t squared plus v of 0, which is 48, times t plus s of 0, which we found to be 20. And there's your final equation relating s, which is the position of the particle, to t, which is the time that has passed.